Test, test. Okay, good morning, everyone. Hope you had a good weekend. How are y'all doing?
Doing good, sir.
Good. Okay. I was looking at our schedule, and we are on track right now to finish up what we're supposed to finish. But I noticed I did not put the day of the final on the schedule, so I just wanted to make that clear to everyone that our final exam is May 12th. That's Wednesday, or that is a Wednesday. It's at 9 o'clock and it goes to 11:45. So today is April 19th. So we are going to have, let's see, May 12th right here. We will not have class on the 10th. So the week of the 10th through the 14th is finals week. We will only meet on the 12th that week and take our final. Okay. So we have, I guess, let me see, today is the April. Today's the 19th. We have 1, 2, 3, 4, 5, 6 class meetings. That's it. 6 left. Okay, any questions? Any questions on homework? I did get the solutions out there, but I was not able to make a video. And that's because I said in my email, I was on Zoom all week and through the weekend, so I didn't have a chance to make a video. Did those solutions help, at least for those of you who went through them? Were you able to figure it out?
Yeah, it helped.
Okay. All right, well, we are going to move on today. The next section on our schedule is Law of Cosines, and we're going to do that. And then we're actually going to do 9.4 today also, even though it's not on the calendar. I want to show it to you. It's very quick. It's just a formula, 2 formulas. And then next class, we'll start chapter 10. All right, so we are now talking about the law of cosines. So last time it was all about the law of sines. And I had given you last time these different cases. Let me get to that. Where was it? Yeah, I'd shown you these different cases, and I told you that I wasn't a big fan of trying to memorize cases. But I told you that there were 4 cases total, and 2 of them we were going to have to wait till law of cosines. So law of sines only dealt with the first 2. So now we're going to deal with the next 2 cases, 3 and 4. So let's go ahead and look at the law of cosines. It's a formula. There's actually 3 formulas, but they're all the same. They're all the same formula, just written with I guess the different sides of the triangle isolated over here. So let me just explain what this does for us. If we have a triangle, and we label the angles, let's say A, B, and C. Excuse me, I've been congested all weekend. It's allergies. If we have a general triangle like this, and again, this is not a right triangle, it's just a general triangle, then if we have 2 of the sides, any 2 sides, and the angle between them. So if we have, let's say, C and B, all right, and we also have A, that's the angle, do y'all see that's the angle between these two sides? So angle A is in between C and B. If we have these three things, then we can always find that side opposite of that angle. That's what the law of cosine says. So I'm going to show you this picture is this equation right here. So it's like, okay, we have B, we have C, here's B, here's C, and we have the angle A. If we know B and C, we can do this. And then if we know the angle A, we can take cosine of A and calculate all of this. And then that'll give us A squared. And so to get A, we just take the square root of that answer. So in order to use the formula, right, we have to do this calculation. I'm not going to go through the proof of why this is true, okay? I just want to make sure that you know that this is on your formula sheet. So if you need to reference it, here it is, law of cosines right here. It gives you all three versions of the law of cosines. So the other two formulas, I hope this makes sense. The other two formulas are if you have that same triangle. And let's say this time you have C and A and the angle between them, then you can always find B by using, let's see, this formula here. Okay. So let's just do an example. So use the law of cosines to solve this triangle. So we know A, we know B, and we know the angle C. Now let's first understand why we can't use the law of sines here. Because remember, we have two rules, right? Two laws, law of sines and law of cosines. Why wouldn't we be able to use law of sines here? And I'll write down the law of sines in case you've forgotten it. Why can we not? Can someone tell us?
Because we don't have a little c.
Yeah, in order for us to use law of sines, we're going to need to know at least one angle and the side that goes with that angle. So like we have the angle C, so we would need little c, but we don't have little c, and we can't get little c. Okay, we can't, there's no way we can figure out what little c is, just it's impossible. Also, if you wanted to use this little a, we would have to have capital A. But we can't get capital A because we only have one angle, we don't have two of them. So if you go back and look at your homework, every single problem that you did, you had an angle and you had its corresponding side given to you. Or if it wasn't given to you, you could find it by using the fact that the angles add up to be 180. So hopefully you see that with this problem, we just cannot do it the way we were doing our problems in the last section. Is that clear? Any questions there? Okay, so because we can't do that, we then realize that we have two sides, A and B, and we have the angle between them. Now we know it's the angle between them because the angle between them should be the letter that's not A and B. So if we have little a, little b, then capital C has to be between them. You can see that from this picture right here. Okay, if we have little a and little b, then capital C is the angle between them. Little a, little b, capital C is between them. So we have law of cosines here. And so what I'm going to do here is I'm going to try and solve for C, little c. And because I'm solving for little c, I'm going to use the version of the formula that has little c isolated. So c squared equals a squared plus b squared minus 2 times a times b times cosine of c. And now it's just plugging everything in. That's all you do. It's just the thing about law of cosines is just as long as you can multiply, add, and use your calculator, you're in business. So c squared equals, let's see, a is 2, so 2 squared, plus b is 3, so 3 squared, minus 2 times a times b times cosine of 60 degrees. Now, what you do need to make sure you do here is do your order of operations correctly here. So I'm squaring the 2, squaring the 3. I'm going to multiply those 3 numbers together. So that should give me 12. And then cosine of 60 degrees. So one mistake I see students make right now is that they'll try and put all these numbers together. You can't do that because this is multiplication right here. So you have to do 12 times cosine of 60. And that you're going to need your calculator for. We're going to get a decimal answer. So 12 times cosine of 60, make sure you're in degree mode on your calculator. So I get 4 plus 9 minus, oh, that just comes out to be 6. Yes, cosine of 60 degrees is 1/2. And then you get c squared equals, let's see, add those up, 13, take away 6, I think you get 7 here. We okay so far? And we're not done. Now what we need to do is just take the square root. So take the square root on both sides, plus or minus 7. And I'm going to throw out the negative. And the reason I'm throwing out the negative is because c is the length of the side of the triangle. So it can't be negative. Any questions? Okay, so now we have little c, right? We have little c. So I'm going to put here, we have little c is root 7. What do we still need to get? What are we missing? So we wanted to get little c, what else?
Big A and big B.
Capital A, right? Capital B, we need those still. Now, how do you think I'm going to get capital A?
Law, we could now use the law of sines.
Now we can use the law of sines. Okay, so now we're going to just resort back to what we did before. Okay, we do law of sines. So I'm not going to show that right now. I want to show you something else first. Okay, so I'm going to take this. Let me take this set of formulas here. I'm going to go to a new page. Okay, so here's our formulas. I want to take this first formula. Okay, just the first one. I want to do something. Okay, so just watch. I'm going to write it down first. Okay. Okay, so watch what I do here, and then at the very end, you'll see why I'm doing this. Okay, so what did I do there?
You move the minus 2 AB cosine C on the other side, and then you move the
To the
C
left
squared
side.
to the right side.
And I move c squared to the right side. Everyone see that? Just move some stuff around. Okay, now watch. So what did I do there?
Divided by 2AB.
Yep, just took both sides and divided by 2AB. It canceled everything else on the left, and we just have cosine of c is this. This is a new formula. All right, this is a new formula that I'm free to use anytime I want to use it. In fact, I could have done that for all 3 of these equations, couldn't I? Couldn't I have done that for all 3 of these? Just move things around. So let's write down what the other formulas would be if I had done that same thing. So let's say I did this one and did everything the same way. Wouldn't I get this? Cosine of b equals a squared plus c squared minus b squared over 2ac. You'll agree that that's what would happen? And then I have a third formula, which is if I did this last one. This one would be cosine of A equals b squared plus c squared minus a squared over 2bc. You are, I'm so sorry, I'm so congested, it's hard to talk. You are allowed to write those three formulas on your formula sheets, okay? And the reason why I'm going to allow you to do that is because on the problem we just did, let me copy this. On the problem that we were just doing, we weren't done, right? We still had work to do here. We had to go find A and B. But what I'm telling you, whoa, it's a little bigger than I need it. What I'm telling you is that instead of using law of sines, we can use these. All right. So let's go find capital A. All right. To find capital A, I'm going to use this formula right here because it has capital A in it. Do y'all see that? So I'm going to write cosine of capital A equals, okay, b squared. What's b squared? For us, that's
3.
3 squared. Okay, so 3 squared plus c squared. C was the root of 7. We solved for that, didn't we? Squared minus a, which is 2 squared over 2 times a times b. Does anyone have a question on what I'm doing here? B squared plus c squared minus a squared. So I'm using the a, the b, and the c here. And then over 2ab, or sorry, 2bc. Oops, I messed up. I don't know, I put 2ab. I just wasn't paying attention. 2 times b times c, which is square root of 7. Please fix that. Okay, now are we okay? All right, so now we have cosine of A equals 9 plus, let's see, square the root 7, we just get 7 minus 4 over, let's see, 6 root 7. So cosine of A equals, we got 15, take away 4. Is that right? No, I'm sorry, 16. Take away 4, we get 12 over 6 root 7. And then we can just get our calculator to do this. Is that right? Let me see here. 2. Uh-oh. Something is wrong here. What did I do? B squared plus c squared minus a squared. I'm getting a number that's bigger. Someone getting 1.41?
No, I got 0.76 pretty much, and then cosine inverse, it came out to around 41 degrees.
Okay, hold on a second. I think I typed it in wrong. Oh, you know what I'm doing?
This is in radians, right?
No, here's the problem. Do y'all see what I wrote down here? I wrote down root 2, not root 7. No, there we go. That's the problem. I had written the root. I typed it in right on my calculator. I just put root 7 and root 2 instead of root 7. Okay, it's going to be one of those days, I guess. Okay, yes. So you get cosine of A equals 0.7559, something like that. Okay. We good? Sorry about that. Now to get A, we do cosine inverse on both sides. Cosine inverse of cosine A, and then cosine inverse of 0.7559. And that should give you that A equals, and when you do that on your calculator, you should get approximately 40.89 something degrees. Okay, now, this is a very important thing to discuss here. Do you remember in the homework and in last class when we were using the inverse sine, we had to possibly check that we had two different triangles? Okay. You do not have to do that with the cosine. And the reason why is because whenever we're saying cosine, right here at this step right here, when we're saying that cosine of an angle A is positive, like 0.759, cosine is the x coordinate, right? And when you're dealing with the inverse cosine, you are only allowed to look in the first two quadrants. And so that the only way we could have a positive x value is if we're over here somewhere. The other place that you could have it would be down here, but we're not allowed to look there, but that's okay because think about the angle here. The angle for a triangle, right, has to be between 0 and 180. It can't be a negative angle. So what I guess I'm trying to get you to see is when we were doing inverse cosine, we were only allowed to look over here, but we had to tell ourselves, well, wait a minute, there is another angle over here that could give you the same y value. And so we had to look at both, right? We had to say, oh, we got to look at both of these scenarios. Here, you don't have to worry about that because we're talking about the x coordinate. And if we're saying the x coordinate is positive, it can only be here. It could not be down here. I hope that makes sense. So I like to use the law of cosines to finish off the triangle because I never have to think about two different cases. And as long as I don't screw up the math like I did, right, initially, as long as I don't screw up the math, then everything should come out fine. So I now know that the angle is 40.89. Right? And then to get B is going to be pretty easy because I have two of the three angles now. So I know that they have to add up to be 180. So I just subtract those from 180 and I'll get my final answer. See if I can do this right. 79.11 degrees. Any questions? No? Okay, so look at this one. Here we have a triangle. We're given all three sides. We are not given any angles, right? So if we have this formula, right, these three formulas are what we use to solve for the sides, right? The three different sides, but you have to have two of the sides and the angle between them, right? But then we said we have three equivalent versions of the formula where it solves for the angles. And in order to solve for the angles, look what you need. It's just all the three sides, right? So I'm going to let you try this right now. Okay, I want you to try it. I'm going to copy these over. I'm going to give you a few minutes. And I'm going to see if you can't solve this out. Okay, so here's the triangle. Here's the formulas. I want you to see if you can find the missing angles, capital A, capital B, capital C. And I'll give you, I don't know, let's go about 6 minutes, see how far you can go. if you have a question, if you're getting stuck or something, just ask, okay?
Is not guilty of a crime.
I put a poll up. Just let me know if you finish, say yes, okay? That way I can kind of see where people are on this. Can somebody tell me what angle they went after first?
I got C first.
You went for C? Okay.
I got A first, then B, and then I did C by
Yeah.
adding A and
By
B.
adding the two. Okay.
Are these formulas on the formula sheet, or do we need to memorize them?
No, they are not on the formula sheet. You can write them on the formula sheet. That's what I said. You can add these to your formula sheet.
Oh, okay. Sorry, my audio must have cut out when you said that.
Okay, I think that's probably enough time. I know not all of you have finished, but this is me going and finding capital C first. You could have done capital A first, capital B, capital C. It's up to you, but I did capital C, and I got that C is 117.28 degrees. So now I have one of the angles. I have to do the same thing to go get either A or B now. I could also use law of sines to go get capital A or capital B. It's again up to me. I think these formulas are easy to use as long as you don't mess up the arithmetic. So somebody who got either B or C, want to tell me what you got for B or C?
For B, I got 26.38.
Okay, 26.38.
For B, I got 31.33.
Okay, well, maybe we should do it then.
For B, I got 26.38 as well.
Okay, let's work through it then. Maddie, did you use the formula?
Yes.
Okay, so you didn't use law of sines? Well, okay, let's use this formula. So cosine of B should be A squared, so 4 squared, plus C squared, which is 6 squared, minus B squared, which is 3 squared, all over 2 times 4 times 6. Is that what you had?
All right, I got 26.38 when I redid it. I must have like
Okay,
missed the button on the calculator or something.
okay. Yeah, so I mean, I made a mistake earlier too. So I mean, that's really where the problems can come in with this, is where if you're just typing things in wrong or not paying attention to a sign or something. So there's room for error on these, but let me see. We get 43 over 48. So cosine of B equals 43 divided by 48. So 0.89583. I take inverse cosine on both sides. Oops. Yeah, 26 0.38 degrees. There. And then once you have those two angles, you can get the third one. So angle A should just be 36.34. There you go. Okay. Make sense? Check this out, just so you can see this. This is just adding just one little thing I wanted to kind of add to this. If this is A, B, and C, this is little a, this is little b, and this is little c. What if I told you, okay, what if I told you, just for the sake of demonstration here, what if I told you that angle C was 90 degrees? Okay, what if I told you that it was 90 degrees? Well, with all of these formulas that I gave you,
The
right,
formulas wouldn't
all of these
apply, would they?
formulas, pardon me?
They wouldn't apply.
Well, how do you mean they wouldn't apply?
Don't they only work for triangles that are not right triangles?
Well, I said that if we have a right triangle, then we do other things, right?
Mhm.
And then law of sines and law of cosines we use for triangles that are not right. But I didn't say you can't. I just said these are the formulas we use when they're not right. But I haven't said you can't use them for right triangles.
Gotcha.
So look at all of these formulas, okay? What would all of those turn into if any of the angles that we had, like either the C, the B, or the A, if any of those were 90 degrees, right? Then what is cosine of 90 degrees?
0.
0. And that would kill off everything over here, wouldn't it? And look at what you'd have. Look at that right there. This is what you'd have. You would have those formulas. And like if you look at this first one, if the angle C is 90, right? So that's that picture I was trying to show you here. If this angle C is 90, then it would look like this now. Here's C, right? A, here's B, here's C. This would be capital A, capital B. That's a 90-degree angle. Do you see that we have Pythagorean? A squared plus B squared is C squared. Do you see that that's what the formula would turn into? Right? If capital C is 90, this all goes away. This is gone. And you just get A squared plus B squared is C squared. So I guess what I'm saying is like the Pythagorean equation, the Pythagorean theorem that I've given you in the past, that is actually just a specific example of the law of cosines when one of the angles is 90. Now, you don't need that. I'm just showing you it's kind of cool that it works. All right, we have another example. So I'm going to let you read this. I'm going to give you about 3 minutes. I'm not trying to get you to work the whole problem. I want you to read it, and then I want to see what you can do in terms of drawing a picture that represents the triangle here. Okay, so 3 minutes. Let's 3 or 4 minutes to see if you can't just come up with a picture for this word problem. Okay, so what do y'all think? Were you able to come up with a picture for this?
Yeah, I think I was.
Yeah? Okay, yeah, so this is hard. If this were a classroom, I'd just like walk around and take a look and see, but all right. I haven't worked this problem out, so let's see. A boat leaves Naples, Florida, going to Key West, 150 miles away. Okay, so I'm just going to draw a picture. I've got a point that we're going to leave. Okay, this is Naples. I'll call it N. And we're going to travel 150 miles away, 150 miles away to some other point. And then I'll put K. So we know that this distance from here to here is 150. Okay, that's what we're supposed to do. Sail from here to here. Right now, I could have drawn that line any way I wanted, straight up to the side, however I want. Okay, I put a little angle. All right. Maintaining a constant speed of 15 miles per hour, but encounters heavy crosswinds and strong currents. The crew finds after 4 hours that the boat is off course by 20 degrees. So they were the way I read this is they were aiming for Key West, but after 4 hours they realized that they're 20 degrees off course. So what they actually did was went 20 degrees off course, and they now find themselves somewhere, right? Is there more? Oh, you know what? Okay, so this is where we are, right? You're 20 degrees. Can you tell me how far we've traveled? How far they've actually traveled?
They traveled 60 miles.
60 miles, yeah, because they're going 15 miles per hour and they've traveled for 4 hours. So each hour they travel 15 miles. So they've gone 60 miles. Understand? So now the question is, they don't want to continue on this course, do they? They don't want to continue doing this, do they? They'll never get there. So the question is, how much do they have to turn their boat by? And how far do they need to go? Okay, so how much, first question, part A, how much do they turn boat? And then B is, how far do they go? How far to Key West? Yeah, Key West. Now, you could have drawn this picture in many different ways, but do you all agree that we all have to turn by the same amount? It might be to the right or to the left. It depends. Like if you did 20 degrees this way, right, then you're going to have to, if you continued straight, you go like this, you're going to have to turn. We're either going to have to turn and go like this, or we're going to have to turn and go like this. And this angle here that we turn by should be the same for both of those. Do y'all see that it doesn't matter which way you do this problem? We should all have the same turning angle. It's just either going to be left or right. Okay, so let me put the triangle that I see here. I see this triangle here like this. I know that this is 150. I know this is 60. No, that angle is 20. And look at that. We have two sides and we have the angle between them, don't we? Two sides and the angle between them. So I'm going to label these sides. I'm going to call this little a. I'm going to call this side little b. And that forces that angle to be capital C. And then this angle would be capital A, and this angle would be capital B. Any questions? Let's get capital A. You know what I'm also going to put on here? I'm going to draw that red line that we would have kept going that direction, because remember, what we want to know is how much do we turn by? What's that angle right there? The reason I'm going after capital A, Okay, the reason I'm going after capital A here is because if you know this angle, right? Let's say you know what that angle is. I'm going to put 2 little dashes on it. Do you all agree that this angle plus this angle has to be 180? So if I can find capital A and subtract it from 180, I'll have how much this is. So that's what I'm going to do. Questions on that? So I'm going to use law of cosines. That cosine of capital A should be b squared plus c squared minus a squared over 2bc. So this should be equal to 60 squared. Hold on. Oh, you know what? We have a problem, don't we? What's our problem?
You don't have the C.
I don't have C. So how am I going to do this then? Right? We have these two.
You have to solve for C.
We have to solve for C. Okay, so do y'all see right now that we can't do this because we don't know what C is, right? We don't know what C is. But because we have the angle C and the two sides, well, the two sides and the angle between them, we can actually get our C by using the law of cosines in the other version like this. So I'll use this to find little c, and then once I find little c, I'll come back in here to get cosine of A. So c squared equals a squared, which is 150 squared, plus b squared, which is 60 squared, minus 2 times 150 times 60 times cosine of 20. All right, these numbers are going to get big. So 150 squared. Are there any questions while I'm doing this? Like the approach I'm taking here? Or why I'm doing any one particular thing? So remember, you have to do all of this first, right there on your calculator. So I get 22,500 plus 3,600 minus 16914.467. So let's see here. I'm getting 9185.533. And then I have to take the square root of that. So I get C is equal to, I'm going to go 95.84. That's this side right here, 95.84. We actually answered part B, didn't we? Part B said how far away, how far do we still need to go? And that would be this distance from here to here, right? That's here to here. That's the distance we need to go. That's part B. And we just found that that was 95.84 miles. Now, how much do we have to turn by? We've got to come back in here and get our cosine of A. So I'm gonna move this over here so I have a little more room. Okay, so now I can come back to this. Cosine of A should be equal to 60 squared plus C, which I just found to be 95.84 squared, minus A squared, which is 150 squared, all over 2 times B, which is 60, times C, which is 95.84. Okay, I'm gonna do all that on my calculator. For the numerator, I get negative 9714.6944 over the denominator. Get 11,500.8. So I get cosine of A is about negative 0.8446. And then I do inverse cosine. If you're off by a little bit, like some rounding differences, that's okay. I get 147 point, let's say 64 degrees. Anybody else get something like that?
I did.
Yeah. Are there any questions? Is this the answer to part A?
No, we gotta subtract.
That's right. This is not it. This is what this angle is, right? I want to know how much we need to turn by. So I need to take, to get this angle, I need to take 180 and subtract the 147.64. Yeah. $32.36. That's how much we should turn by. Okay, so just to recap, you draw a picture. Everybody's picture is going to be a little bit different. And then you figure out what you're looking for here, right? How much we need to turn by and how far we're going to have to travel. And then you just try and start using either law of sines or cosines. The only reason I did law of cosines is because this problem required law of cosines. If I could have done law of sines, I would have done it. And then just work out what C is. Once you find what little c is, then you can go get at capital A. No questions? Okay. That's pretty much it for this section. I mean, it's really just comes down to now you doing problems and practicing. Okay. Did y'all have any problems with the, I gave y'all, didn't I give y'all 2 questions, like bonus questions? Those were test corrections. Remember I told you you could do test corrections? Is that right?
Oh, you gave us.
You gave us one bonus
One.
question.
Was it one bonus? Okay. So it's test corrections and then a bonus question. Those were due before class today, right?
Yes, sir.
So did that go okay with the bonus question?
Yes, sir.
That was all right. I'll look at them first and we'll come back and talk about them next time if you have any questions.
We were supposed to put them in the Dropbox, correct?
You're supposed to put them in the Dropbox. Yep.
Okay, I tried to put them in the Dropbox, but the Dropbox had closed. And I did it, I think I did the same day. Like,
Yeah, I opened it. I forgot I had closed it. So I did reopen it. Did you emailed it to me though, right, Josh? Didn't you?
Yeah, I sent in the email because it was closed.
Yeah. So I got yours. Okay, so we're going to move to the next section. Like I said, this is not on the syllabus, but you will get a question like this on the exam. So, and the reason I'm doing it is because I know in Cal 1 and in Cal 2 this comes up. So I want to make sure that you're aware of it. So area of a triangle. We are all familiar with the formula for the area of a triangle. Now, I don't know why the book uses K, capital K, for the area of a triangle instead of capital A, but that maybe they don't want you to confuse it with the angle capital A, I'm not sure. But coming into this class, everyone should know that the area of a triangle is 1/2 base times height, right? 1/2 base times height. So if you're given any triangle and you know what the base is, right? So B would be this side and H would be this height right here. Then you can always calculate the area by doing 1/2 of base times height. Has anyone ever seen where that comes from? Like how you can get that formula? It's pretty easy to show. Don't want to see it? I'll show it to you real quick. So the way it works is this. If I were to take this triangle, okay, now, oh, you know what? I don't know if I'll be able to rotate this. Yeah, rotate and turn it right, 90. Let me turn it right again. So like if I took this triangle, I put a copy of itself right here like this. Okay, I can't see through it, but do y'all see that the other triangle comes down, comes over like this? Okay, so I have two triangles, right? I started out with one triangle, I created two triangles. The next thing I'm going to do is I'm going to take this piece right here. I'm going to get some scissors and I'm going to cut it right there. And I'm going to take that piece and I'm going to stick it right here. So now it comes right there like this. All right. So what you have now is a rectangle. And this side from here to here is B. And this side from here to here is H. And so the area of that would just be base times height. Yes? But that now is two triangles added up together, the area would be base times height. So if I want the area of one of the triangles, I just take half of that. So that's where the formula comes from. Now you don't need to know any of that. I'm just telling you. I'm just showing you that because it's kind of cool. Get out of there. So we all know coming in here that the area of a triangle is 1/2 base times height, right? But the problem with this formula is that it requires you to know the height. That means the distance from here to here. And a lot of times on triangles, we don't know the height. So like, for example, if we were to take one of the problems we did earlier, like this one. And I said, hey, find the area of this triangle. You don't have the height. I mean, you can see the height is right here from here to here. That distance here would be your H. Problem is you don't have it. It's not easy to get it. Do y'all see that? So we need another formula to find the area of a triangle that does not require the H to be there. So I want to do something, and y'all just tell me whether or not y'all agree with this or not. Okay. Y'all ready? I'm going to call this angle right here C. I'm going to call this side over here A. This side's little c. This is capital A. And that's B up there, capital B. I don't need all these sides. Just I want you to focus your attention on just this, 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 and this. Okay, do y'all see a right triangle right here in red? Y'all see that little right triangle? Okay, I'm going to ask you a question. What is sine of capital C? Based on this right triangle, what is sine of capital C?
H over A.
H over A. Okay. Now, I want you to solve for H. So get the A out of here by multiplying it on both sides. So you multiply A on this side, multiply A on this side, and it cancels out. And now what you have is A times sine of C equals H. Y'all agree with that? Now looking at the whole triangle again, we know that the area of that, we're going to call it capital K because the book calls it capital K, is 1/2 base times height, right? And the base here is B. But we just found a formula for height, didn't we? The height is A sine of C. So this now becomes 1/2 B times A times sine of C, which means all I'm doing there is I'm replacing that H with this, right? That's this formula over here. And that gives us a new formula. And that's what the next little box is. So here's the beauty of this formula. If you know two sides of a triangle and the angle between those two sides, you can find the area. You just have to know two sides and the angle between those two sides. If you've got that, you can find the area. I'll give you the example that comes up in calculus a lot, okay? How about if I give you that, what if I told you that this was an equilateral triangle? That means all the sides are the same. Let's just say that's 5, 5, 5. What's the area? Okay, so you don't have the height, do you? We don't have this height from here to here. That would be the height. We don't know it, right? But do you have two sides and the angle between them? Do you know that angle right there?
Yeah.
What is it?
60 degrees.
60 degrees. Why do you know it's 60 degrees?
Because since it's equilateral, the angles are all the same, and so we can just divide 180 by 3.
Yeah, exactly. If you have all the sides are the same, that means all the angles are the same. And since all three angles have to add up to be 180, you can just take 180 and divide it by 3. That means each of them is 60 degrees. Understand, everyone? 60, 60, 60. So now the area of this, I'll call it capital K, again, because the book does, will be 1/2 of one of the sides, 5, times the other side, 5, times sine of 60 degrees. And that you can do on your calculator. You just do 1/2, which is 0.5 times 5 times 5 times sine of 60 degrees. Make sure you're in degree mode. And you get that the area of that is 10.83. About, I rounded there. So the area of that's 10.83. That makes sense? I think I have an example here. This is an 8. So go ahead and work this on your own. I'll give you about 4 minutes. It shouldn't take you 4 minutes, but find the area of this triangle. And I'll copy this here. Put that in here for you. There you go. Okay, take about 3 or 4 minutes. Go get 12.
Yes, I got 12.
Yeah,
Yeah.
you should get 12 there. That's because sine of 30 degrees is 1/2. So this is a pretty simple problem because the angle's one of our common angles. So what do y'all think? Pretty straightforward formula. You have to have two sides and the angle between them. So if you don't have that, you can't use a formula. All right, so what about if you have a triangle that looks like this? Okay, we haven't looked at this yet, but how about that one that I had up here a second ago? Where is it? This one right here. What if I asked you for the area of this? What could you do? You don't have a height, right? So you can't use the traditional 1/2 base times height. Do you have two sides and an angle between them?
No.
You don't have any angles.
I would use the law of cosines to get the angle, and then we could plug that back into the formula we just start or found.
Yeah, so what angle would you get?
I'll have to see.
I mean, you could do any of them, right? Like you could do C because you have the two sides and then you'd have C, or you could do A and you have 6 and 3, or you could do B and you have 6 and 4, right? So it's really up to you. Y'all understand? Use law of cosines to do that. Does that make sense? Now, there is a way to do it without the law of cosines, but it requires a formula, a new formula. And that's what the last part of this is. This formula is not used very often. The one that I really wanted to show you for this section was this one right here. Please, going into Cal 1, be aware of this formula, all right? But this formula that I'm gonna give you here, Heron's formula, is a formula for finding the area of a triangle if you know all three sides. So if you know all three sides and you don't have any angles, there's a formula to get the area. It is a very weird looking formula. It's the square root of S times S minus A times S minus B times S minus C. Here, A, B, and C are given to us. Those are the sides of the triangle. But S is something you have to calculate. Okay, so what I'm gonna do is I'm gonna take this and go back to this. So I like what Josh said, use law of cosines, but if you didn't want to use law of cosines, you could use this. All right, so let me label some things here. For our triangle, A is little a is 4, little c is 6, and little b is 3. So if I'm going to use Heron's formula, the first thing I'm going to do is figure out what S is. So S would be equal to 1/2 of A, which is 4, plus B, which is 3, plus C, which is 6. So that would be 13 over 2. Add those up, you should get 13, and then divide by 2. That's S. Once you have S, now we go and calculate K. So K will be the square root of S, which was 13/2, times 13/2 minus A, which is 4, times 13/2 minus B, which is 3, times 13/2 minus C, which is 6. And we would have to do all that on our calculator, and it might be easier just to use decimals there. 13 divided by 2 is 6.5. I'm out of room. Did anybody get this yet?
I'm still working on it.
Yeah, me too. Okay. So I get the square root of 28.4375. And when I take the square root, I get the area is 5.33. Josh, did you happen to work it out the other way or no?
Yeah, I just got the law of cosines right now.
Mhm.
So now I just gotta plug it into the last one and we'll see.
Yeah, okay.
Yeah, I pretty much got the same number.
Yeah, there will be some rounding error. Okay. So that's it. What do y'all think? Law of cosines and finding areas of triangles.
Yeah,
Seem reasonable?
not a big fan of the last equation, but yeah, the other ones.
Yeah, I don't like this last equation, and I'll be honest, it's not used very often. But it's there, okay? I'm sure that you could go online. Let's see. So here's a Heron's formula calculator. What were the sides that we just had? They were 6, 4, and 3, or no?
Yes, that's correct.
Okay, so if I go here online, I get the areas calculated 5.3326. Right. So you just need to know more about the fact that the formula exists. In practical application, we'd use a calculator, and this would be almost for all triangles. We'd go to a calculator to solve it. What becomes, let me see if I can explain this. See, the problem is when you get, because you might be sitting here thinking, well, if I can just use a calculator to solve a triangle, why would I do all of this work? Like, why do I have to learn this if a computer can just do this for me? The reason is that in calculus, you're working with triangles where things are still variables. I'll give you an example. In calculus, you might be looking at a problem where this is a classic problem in calculus where you have a person standing on the ground, okay? And then maybe you have an airplane that's flying overhead, okay? That's an airplane. So you have an airplane that's flying overhead, and that plane is maybe flying horizontally going this direction. Maybe it's traveling at like 300 miles per hour. And so let's say you're sitting here and you're looking at that airplane, right? You're looking at it with a set of binoculars, right? And you're sitting there watching it go overhead. And maybe the plane's like 1.5 miles high. And you're watching it, right? It goes overhead. You're watching it with your binoculars. A question in calculus would be, at a specific moment in time, how fast is this angle changing, theta? So another way you can look at it is, I don't know if any of you have stood like at a racetrack or like a train, like at a train station. If imagine you're watching a car come, let's do a racetrack. Okay, so I'll come back to this. Let's say we're looking from the top. Here's a road, and you're standing here, and there's a car coming down the road really fast, and you're looking at that car. Okay, so you're sitting there and you're looking at it. It's real far away and you're watching it. It's coming. Maybe it's going 80 miles an hour. As it gets closer, right, your head has to turn to keep up with the car, right? And initially your head's not turning very fast, but as the car gets closer, it's like, and you have right in here, you're having to turn your head really fast to keep up with the car. But as it goes away, you don't have to turn your head as fast. Does that kind of make sense? So your head is not turning at the same rate all the time. Here in this range, your head is really turning fast and then starts to slow down. That makes sense? So oops, I'm going to show y'all something else. I'll get to my point in a moment, my final point on this. I'm going to bring up my lecture notes from Cal 1. What chapter is this in? Related rates. Yeah, okay, so these are problems. Hopefully you can see this. These are this is like one of the hardest sections in calculus. This is a section called related rates. It's all word problems. Okay, so let me get to the exact example I'm talking about here. So here's that plane problem. Okay, you have a plane, that's you on the ground. Here's the plane flying overhead, all right? And what we're interested in is this angle right here. So I want you to watch this. I'm going to play this. I'm going to slow it down a little bit. Okay. So I want you to pay attention to how fast this is growing. See how it's slow and then goes real fast and then it starts to slowly grow. You'll see that in the beginning, it's slow, 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 and then really fast, and then slow. One more time, slow, 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 speeding up, speeding up, speeding up, faster, 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 slower, slower, slower. Understand? So in a calculus class, what we're doing is we're going to ask this question. We say, okay, the plane's flying over, come on, and then right there, freeze time. How fast was your head turning? At that instant in time, it's turning at a certain speed. Now, an instant later, right there, it's a different speed. So in calculus, you're looking at these instants in time and asking, what's the rate of change, or how fast is something moving or changing or something at an instant? Does that kind of make sense? Kind of. So what you have to do in calculus is realize that this problem all comes down to being a triangle, okay? And a right triangle in this case. You know that this side of the right triangle is 1.5 because, well, that's how high the plane is. You're interested in knowing how fast theta is changing. What's the change in that angle? And you know this distance from here to here, we'll call it x, is the same distance as from here to here, that's x, right? We know how fast x is changing. X is shrinking at 300 miles per hour, right? So this point from here to here is shrinking down. Do y'all understand that? It's shrinking down. But this relationship right now is this. Tangent of theta equals 1.5 over x. And now I have a relationship. This is pre-cal, right? I need pre-cal for this. Pre-cal tells me that for this right triangle, the relationship that I have between theta, this side, and x is this relationship. And now we go and do something. Okay, with this, we do something. And that's what calculus is about. And you'll see when you take calculus, you'll see what you do. But my point is that in calculus, one of the sides of the triangle oftentimes is a variable. So you can't just, this isn't, in calculus, it's not about, oh, go solve this triangle. So just go to a computer and figure out what all the sides are. No, in calculus, there's always something that's a variable. And so it's not as simple as just finding a simple numeric answer. I hope that makes sense. If that were the case, we just use computers to do it for us, and that would be it. But we can't. So I hope that that kind of makes sense as to why we, why we just don't use a website or something to solve triangles all the time. It's because a lot of times in calculus, one of these is left to be a variable, x or something. Okay, we have 20 minutes. Let's. I don't want to start the next section because it's a whole new chapter. So I'm going to let y'all go. I'll hang out for a few minutes if y'all have questions. The homework for this section, get that done. I have no homework for this section on areas of triangles. There's no homework assigned, okay? But you do have homework on the 9.3 law of cosines. Question?
Will the area of triangle sections be on the final exam?
If I ask it, it would be a bonus question because it's not officially in the syllabus.
Okay, thank you.
Yeah, and on your formula sheet, Heron's formula is not there. And also the area of a triangle. Okay, see this right here, area, this is geometry, first reference page. Area is, oh, whoa. You see it says area is 1/2 base times height. That's your traditional formula. But they also give you 1/2 AB sine theta. There it is. A and B, two sides and the angle between them. If you know that, then you can find the area. There it is. Okay, so that's there, but Heron's formula is not. But you can also use law of cosines like Josh was going to do to.
Heron's formula is k equals the square root of s times s minus a times s minus b times s minus c, right?
Mhm.
Can we write it on the formula sheet or do we?
Yeah, I
just-
don't mind if you write it here. Just keep in mind that, you know, if you take Cal 1, they may not let you have that written on the sheet. You probably won't need it. I've never used Heron's formula in calculus 1 or 2 or 3. Like when I'm teaching those courses, I've never used it. So. Okay, everyone have a good day.
Thank you.
I'll hang out here if you have any questions.
Thank you.
Okay.
Good one.